In today's video, we're going to look at the two types of distillation that we can use to separate out mixtures that contain liquids. Let's start with simple distillation, which is used for separating out a liquid from a solution. For example, we could use simple distillation to separate pure water from seawater. Before we cover how it works though, we need to be familiar with the equipment. First, we have a flask that contains the solution, or the liquid mixture, that we're trying to separate. And the flask is sealed at the top with a bung, so that no gas can escape. We then put a thermometer through the bung so that we can measure the temperature inside the flask. Next, we have our condenser, which consists of a main pipe surrounded by a water jacket, which contains a stream of continually flowing cold water, with the water being fed into the water jacket at the bottom and coming out at the top. Then, beneath the end of our condenser, we'll have some sort of beaker to capture our pure liquid. And finally, we're going to need some sort of heating device, like a Bunsen burner, which we place under the flask. Our first step is to heat up the mixture, so that the liquid that we want evaporates. As it rises to the top of the flask, the pressure will force it down the condenser. And because we're pumping cold water through the water jacket, the vapor will cool and condense into liquid form, which will then run down the pipe and collect in the beaker. So in our case, as we heat the seawater, we'll get more and more pure distilled water, until eventually all we have left in the flask is salt. Now imagine instead that we were trying this technique with a different mixture, one containing some different liquids, like methanol, ethanol, and propanol. Because these liquids all have similar boiling points, when we heat them, more than one of them will evaporate, and so they won't be separated into pure substances. In this case, we'd have to use a different technique, called fractional distillation, which is the main technique used for separating mixtures of liquids. The equipment for this is pretty similar. But instead of the gas passing straight from the flask into the condenser, the vapors have to first pass through a fractionating column, which has two key features. One is that it's full of little glass rods, which provide a really high surface area. And the other is that because the column is so tall, it's actually cooler at the top than it is at the bottom. To understand why this is important, let's imagine that we were trying to separate those three liquids that we mentioned before: methanol, ethanol, and propanol, which all have similar boiling points, although you don't need to remember them. And before we continue, just be aware that in real life, these would all be colourless, not green. We're just showing them as green to make it easier to follow along. Now, because methanol has the lowest boiling point, we'd heat the mixture to around 65 degrees first. This would cause the methanol to evaporate, and then rise up the fractionating column. It would then pass into the condenser, and condense into liquid methanol, which we would then collect in our beaker. However, just by chance, some of the ethanol, and maybe even propanol, would also evaporate. But as they rise up the fractionating column, and come into contact with all of those glass rods, which are much cooler than their boiling point, they'd condense back into liquid form, and fall back into the flask. This means that the only liquid that will get out the other side will be pure methanol. The next step would be to do the same thing all over again for ethanol, by raising the temperature to around 78 degrees Celsius, which would allow us to evaporate off the ethanol. At this point, all that should be left is the propanol. So we could just assume that what we have in the flask is pure propanol. Or we could raise the temperature again to boil off the propanol, just to make sure. Anyway, that's all for today. So hope you enjoyed this video. If you did, then please let us know down in the comments. And we'll see you next time.